time become death, the destroyer of worlds. I suppose we all thought that, one way or another.
In the annals of history, there are those rare individuals whose brilliance and ingenuity shaped the course of humanity. Today, we delve into the life of one such enigmatic figure, Robert Oppenheimer. A renowned physicist and the driving force behind the development of the atomic bomb during World War II. His groundbreaking contributions to theoretical physics brought him acclaim among his peers. Yet, it was a call to arms during World War II that catapulted him into an unprecedented scientific endeavor. So join us as we explore the life and times of Oppenheimer and most especially, the top secrets of how the atomic bomb was developed and used during World War II. Robert Oppenheimer, one of the most brilliant minds of the 20th century, was born on April 22, 1904, in New York City. He grew up in an affluent and intellectual family that valued education and culture. His father, Julius Oppenheimer, was a successful textile importer, while his mother, Ella Friedman, was a painter and a talented pianist. This nurturing environment laid the foundation for Oppenheimer's later pursuits in academia and science. From a young age, Oppenheimer exhibited extraordinary intellectual curiosity and a voracious appetite for knowledge. His early academic achievements were exceptional, and he showed remarkable talent in mathematics and languages. He attended the Ethical Culture Fieldston School in New York, where he excelled in his studies and demonstrated his innate scientific aptitude. Oppenheimer's passion for science blossomed during his undergraduate years at Harvard University. He pursued various subjects, including chemistry, literature, and philosophy, but he was particularly drawn to physics. His insatiable curiosity and tenacious work ethic caught the attention of his professors, who recognized his exceptional potential as a scientist. After graduating summa cum laude from Harvard in 1925, Oppenheimer set his sights on furthering his scientific education. He embarked on a journey to the University of Cambridge in England, where he continued his studies in theoretical physics. At Cambridge, Oppenheimer encountered the influential physicist J. Thomson, who mentored him and guided him through the intricacies of the field. Under Thomson's tutelage, he gained a deep understanding of quantum mechanics and its applications to theoretical physics. During his time at Cambridge, Oppenheimer immersed himself in the vibrant scientific community, engaging in stimulating discussions with fellow students and leading researchers. His passion for theoretical physics flourished as he delved deeper into the quantum world, exploring the mysteries of subatomic particles and the fundamental laws of nature. Robert Oppenheimer's journey into the world of theoretical physics led to groundbreaking contributions that reshaped the field. His work on quantum mechanics played a pivotal role in advancing our understanding of the subatomic world and laid the groundwork for future scientific discoveries. Oppenheimer's fascination with quantum mechanics led him to study the behavior of subatomic particles, their wave-particle duality, and the uncertainty principle. He delved into complex mathematical equations to describe the behavior of electrons and photons, seeking to reconcile the dual nature of these particles. His theoretical investigations resulted in seminal papers that garnered attention within the scientific community. One of Oppenheimer's most significant contributions was his research on the Born-Oppenheimer approximation, developed in collaboration with the German physicist Max Born. This approximation provided a powerful tool to separate nuclear and electronic motion in molecules, revolutionizing the study of chemical reactions and molecular structures. The Born-Oppenheimer approximation remains a fundamental concept in quantum chemistry to this day. Oppenheimer's collaborative nature extended to working with other prominent scientists of his time. He collaborated closely with his student Melba Phillips on studies related to the quantum theory of molecules. Additionally, he formed a fruitful partnership with the theoretical physicist Hans Bethe, working on quantum electrodynamics and its applications to astrophysics. These collaborations allowed Oppenheimer to engage in deep discussions and exchange ideas with fellow physicists, fostering an environment of intellectual stimulation and creativity. His ability to tackle complex problems and provide novel insights earned him a reputation as one of the brightest minds in the scientific community. His brilliance caught the attention of leading physicists worldwide, and he received several prestigious awards and fellowships, including the Guggenheim Fellowship and the National Academy of Sciences Award in Theoretical Physics. These accolades recognized Oppenheimer's exceptional contributions to theoretical physics and solidified his position as a prominent figure in the field. The circumstances that led J. Robert Oppenheimer to lead the top-secret Manhattan Project during World War II were driven by the escalating global conflict and fears that Nazi Germany might be developing nuclear weapons. With the discovery of nuclear fission by German scientists in the late 1930s, the United States recognized the potential devastation that atomic weapons could bring. This realization prompted the U.S. government to initiate a research program to investigate the feasibility of building an atomic bomb. Oppenheimer's reputation as a brilliant physicist and his pioneering work in quantum mechanics made him an ideal candidate to head the project. In 1942, he was appointed as the scientific director of the Los Alamos Laboratory, the central facility for the Manhattan Project. His leadership role was essential in coordinating the diverse scientific efforts required to develop the atomic bomb. One of Oppenheimer's key responsibilities was assembling a team of exceptional scientists to work on the project. He handpicked top minds from various scientific disciplines, including theoretical physics, experimental physics, chemistry, and engineering. Oppenheimer believed in fostering an environment that encouraged innovation and creativity, which led to an exceptional level of collaboration among the scientists. However, assembling such a diverse group of brilliant minds came with its own set of challenges. The scientists often had different perspectives and approaches to problem solving, leading to occasional conflicts. Oppenheimer's role as a leader was crucial in mediating these conflicts and ensuring a productive and focused working environment. The Manhattan Project faced immense challenges throughout its development. The sheer complexity of building an atomic bomb, which had never been done before, required groundbreaking research and engineering. Scientists and engineers had to work with limited resources and under tight time constraints. The project also confronted profound ethical dilemmas. The realization of the bomb's destructive power raised serious questions about the moral implications of its use. Oppenheimer and many scientists involved in the project grappled with the ethical responsibility of creating such a weapon of mass destruction. This internal struggle was reflected in Oppenheimer's famous quote from the Bhagavad Gita after witnessing the successful test of the atomic bomb: "Now I have become death, the destroyer of worlds." Despite these challenges and ethical concerns, the Manhattan Project ultimately succeeded in developing the atomic bomb. On July 16, 1945, the first successful test, codenamed Trinity, took place in the New Mexico desert. The successful development of the atomic bomb marked a turning point in human history. The bombings of Hiroshima and Nagasaki in August 1945 brought an end to World War II but also ushered in the nuclear age and its associated arms race and geopolitical tensions. The successful test of the first atomic bomb, codenamed Trinity, was a momentous event that took place on July 16, 1945, in the desolate New Mexico desert. It was a critical milestone in the top-secret Manhattan Project, the United States research and development program aimed at building an atomic bomb during World War II. The Trinity test used an implosion-type device fueled by plutonium. At precisely 5:29:45 a.m., the bomb detonated, releasing an explosive force equivalent to approximately 20,000 tons of TNT. The intense heat generated by the blast vaporized the steel tower used to suspend the bomb, leaving behind a crater almost 10 feet deep and 1,200 feet in diameter. A towering mushroom cloud rose more than 7 miles into the sky, marking the advent of a new era, the nuclear age. The implications of the successful Trinity test were profound and far-reaching. With the demonstration of the bomb's devastating power, the world realized the unprecedented capacity to release a catastrophic amount of energy by harnessing the process of nuclear fission. This realization had significant implications for world history, as it signaled the beginning of the nuclear arms race and heightened tensions between major world powers during the Cold War. On August 6, 1945, the United States dropped the first atomic bomb on the Japanese city of Hiroshima, and on August 9, 1945, a second bomb was dropped on Nagasaki. The bombings resulted in the immediate death of tens of thousands of people and brought about the surrender of Japan, effectively ending World War II. The use of nuclear weapons in warfare raised profound ethical questions about the consequences of such actions and the moral implications of wielding such destructive power. One of the most notable debates and controversies surrounding Oppenheimer's involvement in the Manhattan Project emerged during the McCarthy era. Despite his pivotal role in the successful development of the atomic bomb, Oppenheimer faced accusations of being a security risk due to his past associations with left-wing organizations. In 1954, his security clearance was revoked after a highly controversial security hearing. The security clearance revocation was a significant blow to Oppenheimer's career and reputation. Many viewed it as a politically motivated decision influenced by anti-communist sentiment during the era of McCarthyism. The controversy over Oppenheimer's case continued for decades, with supporters advocating for the restoration of his reputation and acknowledging his immense contributions to science and the war effort. After World War II, Robert Oppenheimer's contributions to science and education continued to leave a lasting impact on various fronts. As the war came to an end, he shifted his focus towards advocating for international control of atomic weapons and shaping science policy to ensure responsible use of nuclear technology. Oppenheimer played a pivotal role in advocating for international cooperation and arms control to prevent the proliferation of nuclear weapons. He was a key figure in the newly formed United Nations Atomic Energy Commission, where he emphasized the need for a global approach to managing nuclear technology. His belief in the importance of international agreements and the peaceful use of nuclear energy was evident in his active participation in efforts to establish the International Atomic Energy Agency, IAEA, in 1957. Beyond his involvement in arms control, Oppenheimer also made significant contributions to science policy. He served as the chairman of the General Advisory Committee, GAC, of the newly formed Atomic Energy Commission, AEC. In this capacity, he provided important advice and recommendations on various aspects of nuclear technology, including its potential applications in both civilian and military sectors. His dedication to science education remained unwavering after the war. He took on numerous roles as an educator and administrator. In 1947, he became the director of the Institute for Advanced Study at Princeton, where he fostered an intellectually stimulating environment and supported cutting-edge research in various fields. He also played an instrumental role in developing the California Institute of Technology's, Caltech, Institute for Nuclear Studies. As an influential educator, Oppenheimer mentored and inspired a new generation of scientists, many of whom went on to achieve significant breakthroughs in their respective fields. His impact on shaping the scientific community extended far beyond the boundaries of his own research. Despite facing controversies and challenges throughout his life, Oppenheimer's contributions to science and his enduring legacy as an educator and influential figure remain an inspiration for generations to come. His unwavering commitment to pushing the boundaries of knowledge and his profound impact on the nuclear age continue to shape the world of science and policy, leaving a lasting imprint on the quest for understanding the fundamental nature of the universe.